So what we're looking at today is dealing with more arcs and line segments. Now, our first theorem that we're going to look at is a tangent and an intersected chord theorem. So if a tangent and a chord intersect at a point on the circle, then the angle measure formed is 1/2 of its interpreted arc. So for angle 1 here is going to be half of the measure of arc AB. Angle 2 is going to be half of the measure of arc BCA. So all we have to do is if we have one of them, we can either divide it by 2 or we're going to multiply it by 2. Because if I have the angle measure, angle 1, I can multiply it by 2 to find its arc. Or if I have the arc, I can divide it by 2 to find the angle. So if we look at this first one here, this first problem, they told us that arc AB, the measure of arc AB is 130. Well, I know that the measure of angle 1 is equal to 1/2 the measure of arc AB. So we would take 1/2 times what? 130 degrees. Because the measure of the angle is equal to half the measure of the inscribed arc. So we would take 1/2 times 130, or 130 divided by 2, and find out that the measure of angle 1 is 65 degrees. So since we were given the arc, we could divide it by 2 to find the angle. Any questions on this here? So let's look at this one here. Now this time they didn't give us the arc, the measure of the arc, they gave us the measure of the angle. Well, one of those was correct. Now we said the angle, if we're given the angle, it's equal to half the measure of the arc. So if the measure of the angle, measure of angle L, because it would be KL and whatever our letter is, well, it'd be N. I'd have to name it N because we don't have one. KLN would be 1/2 the measure of arc LJK. But we don't want to know what the measure, we don't have the measure of the arc, we have the measure of the angle. So what we would be saying is that 125 is equal to 1/2 the measure of LJK, the arc we want to find. Bless you. So really we need to multiply both sides by 2 to see the measure of arc LJK is 250. Or really we could have just multiplied the angle by 2. Because if we're given the arc, we divide it by 2 to get the angle, the inscribed angle. Or if we're given the inscribed angle, we can multiply it by 2 to get the arc that it is made up of. Any questions on any of this here? So let's look at the next one. So this time I'm wanting to find angle 1. Well, we know that this angle is equal to half the measure of the arc. Well, the arc is 240 degrees. So the measure of angle 1 is going to be 1/2 of 240. Bless you. So we can do 1/2 times 240, or 240 divided by 2 in the calculator. And we would get 120 degrees. Any questions on any of this here? All right, let's look at the next one here. Now this one here, they gave us the angle of 155 degrees, and we want to find its arc. Well, we know that the angle is equal to half the measure of the arc, and the arc is equal to twice the measure of the angle. So for this here, if I want to find the measure of arc LJK, I have to take our angle and multiply it by 2. So we would do 2 times 155. And we would get. So when we talked, so the formula for this here is telling us that the measure of our angle, the angle inside, so we could call this here M, angle MLK, is equal to 1/2 the measure of the arc. The measure of the angle that's formed by the tangent line and the chord is equal to 1/2 the measure of the arc. So whatever this arc measure is, half of it would be 155. So if I go the other direction, well, if the arc is half, the measure of this angle is half the arc, well, the arc is twice the angle. Because what we're saying is, we can write it in a different way, is do I know what the measure of the arc is? Well, no. But I know that 155 is equal to 1/2 times whatever that measure is. Now, the easiest way to undo this 1/2 is if I multiply both sides by 2. Because here we get 2 times 1/2 times x. Well, 2 times 1/2 is 1, or we just have x. Now we can do 2 times 155, 0 carry the 1, and we get 310. So the measure of the arc would be 310. Any questions on these here? Does that make more sense? So if we're going from the angle to the arc, it's getting bigger. If we're going from the arc to the angle, it's getting smaller. Any other questions on this here? All right, let's look at the next one. So they're asking us to find the measure of angle 1. So should the angle be bigger or smaller than the arc? Smaller. It's getting smaller. So we're dividing 210 by 2, or we're multiplying 210 by 1/2. And we get that the measure of angle 1 is 105 degrees. 105 degrees. Any other questions on any of this here? All right, let's look at this one here. So we're told that the angle is 98 degrees. We want to find the measure of arc RST. Well, we know the measure of RST, arc RST, is equal to twice the measure of the angle. So we're going to multiply the 1 by 2. We're going to multiply 98 by 2. Well, 98 times 2 is 196. 196 degrees. Any questions on any of this here? You feel pretty comfortable with this formula? How this formula works, going from angle to arc or arc to angle. Okay. We feel comfortable with this here. We will move on. Intersecting lines and segments. Now, if two non-parallel lines intersect a circle, there are 3 places where the lines can intersect. They can either intersect on the circle, in the circle, or outside of the circle. Are the 3 places where the 2 lines can cross. Now, we've already talked about on the circle, because if 2 lines intersect on the circle, that's called an inscribed angle. And an inscribed angle is equal to half the measure of its arc. Now, inside of the circle and outside of the circle are what we're going to be covering next. So if 2 lines intersect inside the circle, then measure the angle that is created, so angle 1 here, is equal to half the sum of these two arcs, the two arcs that are created from those two lines crossing. And the same is true for the other angles. And that's going to work for any two lines that intersect inside the circle. Now, if we have two lines that intersect outside the circle, that angle is going to equal 1/2 of the bigger arc minus the smaller arc, no matter where it is located. BC, bigger minus AC, smaller. PQR, bigger minus smaller. XY, bigger, WZ, minus smaller. So if it intersects outside of the circle, we're always going to do bigger minus smaller. 1/2 of bigger minus smaller. It might be a little bit easier if we look at an example of this here. So when we look at this here, we have two angles, or two lines that intersect inside the circle. So we have two lines that intersect inside the circle. Now our angles that we work with, x here, is always going to make up the two here. So x is going to equal 1/2 of the sum of the two arcs. So what's one of our arcs going to be? And 156. Well, at this point here, we could plug this whole thing into the calculator, because since we have all the numbers on the same side, 1/2 times 130 plus 156, we would get an answer. Now, we can do 130 plus 156 in the calculator, which would give us 286. And if we multiply it by 1/2, we get that this here would be 143 degrees. Any questions on any of this so far? Yes. Okay. Now, the measure of angle x for either one of these here will not be the same as 156 or 130 because that's not a central angle. Because x is not a central angle, it's not going to be the same as 156 or 130. Yes? Yes. Inside will be adding, outside will be subtracting. So when we look at the next one here, this one here, since the angle is outside, where the two lines intersect is outside of the circle, we would be subtracting. So when we look at this one here, x, the angle where the two lines intersect, where that's formed, would be by itself, is equal to 1/2 of the bigger arc minus the smaller. So our bigger is 178, our smaller is 76. So we're always going to do bigger minus smaller. So we're going to do 178 minus 76, which would give us 102. And if we take 1/2 times 102, we get 51 degrees. So the measure of angle x would be 51 degrees. Yep. When it's outside the circle, we're going to do bigger minus smaller. When they intersect inside the circle, we're going to add the two arcs together. Any questions on this here? So this here, since the two lines intersect inside the circle, we would be adding, yes? Now, if we look at this here, there is a little bit of math that we do need to do. Because the 94 is placed here, I'll say that this is y and z. Well, 94 would equal 1/2 of whatever x plus z, or not x, y plus z is, because it's going to be those two out there. But that doesn't really help us much, does it? Because the inside angle, that angle is equal to the sum of its two arcs. So 94 would be equal to the sum of y plus z times 1/2. Well, that's not what we want to find, because we don't really care about the measure of y or z, because it's not asking for either one of those. But what is it asking for? X. So we're not worried about any of those. But it would be helpful to know which angle. Because would there be an angle that would be nice to know? Here? Either one of these here would be nice to know, because if I know one of those two, then we can use our formula to find out what x is. Is there a way that I could find one of those two? 94 from 180, because the measure of a straight line adds up to be 180 degrees. A straight line is 180 degrees. So if I want to know one of those two, we can take 180 and subtract 94. We would get 86. Well, actually, both of those angles would be 86 degrees, because the one angle is 94, and they are both vertical angles. So, this here, so it is 86, yes? And we're saying 86 is equal to 1/2 of what? 80 plus x. Those two arcs added together times 1/2 would give us 86. So it's not just one of them, because since where they intersect, that point of intersection that creates these angles is not at the center of the circle, they won't directly relate to it. Now, we do have the equation. Are there any questions on how we got to this point here? Okay. Now, there's two directions we could go. The first one is that I can multiply the 80 and the x by 1/2. 80 is divisible by 1/2, or 80 times 1/2 would give me 40. That works out fine, yes? Can I divide x by 2 evenly? No. So what we can do instead is I can multiply both sides by 2. Because 2 times 1/2 is 1. Because over here we would have 1. Here, the 2 times 1/2, well, that would become 1, so I'm left with 80 plus x. So multiplying by 2 is a nice way to simplify that 1/2, especially if I just have x by itself. What do we need to do next to get x by itself? Subtract 80 from 172. And that tells me x is equal to so the measure of arc, that arc, or the measure of x, is 92, which makes that arc 92 degrees. Any questions on any of this here? Are we good with this here? Yes? Okay. Let's look at another one. So this time here we do have the angle outside the circle, so we're going to do what? Well, 35 is going to be equal to what? 1/2 of 100 minus x, because the bigger is always going to be the farther one away. So the 100 would be the bigger arc, x would be the smaller. Right. If we can multiply both sides by 2, because on the one side here, 2 times 35 would give us 70. We can do 2 times 35 in the calculator, or we can multiply by 2. 2 times 5 is 10, so 0 carry the 1. 2 times 3 is 6, plus 1 is 70. Now our 2 and 1/2 will cancel out, leaving us with 100 minus x. Yes, we would minus 100 from both sides. Well, 70 minus 100 is? That's interesting. So is the value of x negative 30? We need to multiply or divide by negative 1. Either one will work. If I divide both sides by negative 1, we get the value of x is 30. Yes. So for this one here. Any other questions on any of these here? Find the value of the variable. Well, if we knew one of these two angles, we could find the value of y, yes? Yes, we can do 180 minus 102, because 102 and the angle we want do make a straight line. And a straight line always has this angle of 180. And if we subtract these two, we would get 78. So either one of these angles here is 78 degrees. And it doesn't matter which one we have, because it will give us the same formula. And since we found 78, well, it tells us that 78 is equal to 1/2 of y plus 59, or not 59, 95. So any questions on how we got this set up for anything we've done so far? Okay. At this point here, we can multiply both sides by 2. And we can do 78 times 2, which would be 156. Here, the 1/2 and 1/2 would cancel, leaving us with y plus 95. And last but not least, we can minus 95 from both sides. Which would tell us y is equal to 61, yes. Any other questions on any of these here? All right, let's look at one. Let's see here. Yep. Let's look at this one here, and then we'll look at the last type that we're going to look at today. So if I look at this here, it pretty much gave us everything. The exterior angle is equal to what? 1/2 of? A minus 44. Since it is outside of the circle, we always do bigger minus smaller. Now, since it's everything inside the parentheses is not divisible by 2, it's going to be a little bit easier to multiply everything by 2 first. In doing so, well, 2 times 30 is 44 to both sides. A is equal to 104, 104 degrees. Any questions on any of this here? Sweet. We have the last theorem that we're going to look at. A circumscribed angle is an angle whose sides are tangent to the circle. So we have two tangent lines. The measure of a circumscribed angle is equal to 180 minus the measure of the central angle that intercepts the same arc. So, if I have a circle, two tangent lines, and this setup here. So I'm going to go through and kind of show you why this works, and this one works out nicely, at least nicely enough that we can see this. If the lines are tangent, we know that they form a right angle, yes? Because that's why they're tangent. We went through in the first section or the second section kind of showing if a line is tangent to a circle, it should make a right angle, and we used the Pythagorean theorem to show it. Well, this shape here has how many sides? 4, yes? So the sum of the interior angles of a 4-sided figure is 360, yes? So the sum of all these angles is 360 degrees. I know what two of them are, 90 and, well, 90 and 90 is 180. So that tells me that these two angles here have to add together to be 180 degrees. Now the theorem mainly talks about the fact that the exterior angle, ADB, is equal to 180 minus ACB. But since I know the two add together to be 180, it can go in either direction. Because if I know what the exterior angle is, I know that it's equal to, the interior angle is equal to 180 minus that exterior one. Because these two angles have to add together to be 180. That's kind of helpful and nice to know. So if we look at this first example, if I want to find the measure of x, I can subtract 135 from 180 because I know x and 135 have to add together to be 180. We get what? 45. So the measure of that angle is 45 degrees. So this one here, we're looking for the central angle, x, and we can just subtract 180 from 30, yes? Is that a central angle? Well, no, it's actually an inscribed angle, yes? Well, I know, let's see here, it'd be helpful if I can write on the board, that this angle x is an inscribed angle, yes? So it's equal to half the measure of arc EF. Because whatever that arc is, it's half of it. Would we agree with that there? Because we covered inscribed angles, they're equal half to half the measure of their given arc. Now it's not drawn, but we know that the central angle here is the same as this arc measure, yes? So if I wanted to, I could really modify and kind of say that this is equal to 1/2 the measure of angle FGE, that central angle. Well, as we just said, this central angle is equal to 180 minus 30, yes? So this one here required us solving for a few things first. $150, and half of 150 is 75 degrees. Are there questions on this here, or how we went about doing this one? Because this one did require a few more steps than what we've done previously. Questions on this here, how we did this? Now, this isn't the only way we could have done this. Since the formula we've been going over, well, we know that this arc and the central angle are the same, yes? So I could have found that by taking 180 and subtracting 30 from it, yes? Which would give us 150. So I know that this is 150 degrees. I'm wanting to find the inscribed angle, and well, the inscribed angle is equal to half of 50, so x would be 75. We could go about it either way. All right, let's look at this one here. We want to find the measure of angle x, and they gave us the central angle of 124 degrees. So, x would be equal to what? 124, because again, those two angles have to add together to be 180. So if we do 180 minus 124, we should get 56 degrees. Any questions on any of these here? Do we feel comfortable with these here? We at least want to see this one here one more time, because this one here is a little bit more tricky than the other one. Now this one here, we do have to do a few steps, because angle x is not the central angle. We do need to find out what that arc is, because whatever the measure of that arc is, x is equal to half of that measure. So we could say 1/2 of the measure of arc AC. But as we saw already, AC is really equal to 180 minus 42, because the central angle and that arc are going to be the same. So really that arc and that exterior angle should add together to be 180. Well, 180 minus 42 is going to be 138. And if we take half of 138 or divide 138 by 2, we get 69 degrees. Any questions on any of this here? Are we good with this problem here? I know that y'all are comfortable with this one here because this one's pretty straightforward. But do we want to see at least one more of these here? Are we comfortable with these here dealing with an inscribed angle and an outside angle? So that leads us to this problem here. And this problem here is not in the notes. I was looking over the assignment and I wanted to include this one in as well. Because there will be one of these on your assignment. Now this is still dealing with that same formula that we were just using. Same creates the center of the circle and our inscribed angle. Now we need to go about finding x, or finding the value of x. So I'll give you a second if y'all want to draw this in. Now there's different ways we can go about solving this. Now, what do we know about an entire circle? Its degree measure is 360. So the side that has 15x plus whatever the arc FH is should add together to be 360 degrees, yes? Because an entire circle adds together to be 360. So we could take 15x plus whatever this is equal to 360. Because the space that's left, we can put in the measure of arc FH. Yes. So the space that I left here is our measure of arc FH, because that one plus 15x should give us 360 degrees, and it will. Now we can find FH because FH is the same as the central angle. Now to find the central angle, well, I know that the central angle and 45 add together to be 180. So we can do 180 minus, to get 135 degrees. So our central angle for this here is 135 degrees, which means the arc is 135 degrees. So 15x plus 135 is 360 degrees. Now at this point here, to solve for the value of x, we would subtract 135 from both sides. And at this point here, we would divide both sides by. We see that x is equal to 15. And that is it. Are there any other questions on anything we have done so far today?